is the relationships between exterior angles of a triangle. So a couple things to designate here. First, just what is an exterior angle? If you take a triangle and extend one side of it, okay, so let's say we have this triangle with angles 2, 3, and 4, and we extend the side EF to form angle 1. This angle that's formed right here is called an exterior angle. Okay, so an exterior angle is defined as an adjacent angle formed by extending one side of a triangle. Okay, so exterior angle 1 is adjacent to one of the interior angles. And the other two interior angles, so in this case angles 3 and 4, are called remote interior angles. Right, so if you're comparing angles to or referencing them with respect to the exterior angle, the remote interior angles are going to be the non-adjacent interior angle pairs. Right? And the property that exists for these is that the exterior angle itself of any triangle is equal to the sum of the remote interior. So again, if we base it off of this diagram right here, the relationship that exists is the measure of angle 1, that exterior angle, is equal to the sum of the remote interior angles 3 and 4. Okay, so if we take the example provided here, or the first sample problem, if you're told that angle 1 is 110, angle 3 is 30 degrees, and they ask you what is the measure of angle 5, okay, the relationship is your exterior angle is equal to the sum of the two non-adjacent interior angles, the remote interior angles. And so what would angle 5 have to be? If 110 is going to equal 30 degrees plus measure of angle 5 is going to be, subtract 30 from both sides. So you get that to be 80 degrees.
Is there going to be a problem where they would just give you the adjacent interior angle and then you can just solve it like a linear pair?
So that's one of the things that you're going to find is using exterior angles isn't always a necessary relationship because you can always wind up finding, like on this one even, if you said what would be the linear pair angle 2 in this case? 70 plus 30 leaves what for angle 5? You can still solve it using sum of angles. It's just a shortcut, and you guys, you'll probably start to see most of you will use the sum of the angles more often than this. But once you can see this relationship, it'll save you time, and I'll try to point that out when it comes up. But there will be cases where if you use this, it's a quicker way to approach the same relationship.